The second data release of ESA's Gaia mission has produced an extraordinary catalogue of over 1.5 billion stars in our galaxy. Based on observations between July 2014 and May 2016, it includes the most accurate information yet on the positions, brightness, distance, motion, color, and temperature of stars in the Milky Way, as well as information on asteroids and quasars.
The data comes down to the ESA antennas on the S-track network in Argentina, in Spain, and in Australia. From there, it goes to Darmstadt, who control the spacecraft, and then it goes to our central data processing hub near Madrid in Spain, which is an ESA center. And from there, it goes to the data processing consortium, which then slices it up in different parts and processes this into science products.
This new image, showing the distribution of stars in the Milky Way, represents 22 months of observations. 1.7 billion stars, their distance, motions, and color. The dark areas are not empty. They contain interstellar gas and dust.
So Gaia is measuring with 3 different instruments. It is doing astrometry, photometry, and spectroscopy. So astrometry is measuring the positions, which helps to get the distances and also the motion of the stars. Photometry is essentially getting the color of the star, and color gives us the temperature of the star.
This stunning new image was produced by recording the color from stars and combining it with their overall brightness. We now know the position and brightness of 1.7 billion stars. Importantly, as well as the color, we also know the distance and proper motion of 1.3 billion stars, plus the surface temperature of 161 million, the radius and luminosity of 77 million, and the radial velocity of 7 million stars.
With spectroscopy, we are using one element which is based on Doppler effect. We are looking how the lines on the spectra are moving, and we get the speed of the star on the line oscillate. But spectroscopy can be also used to analyze better the stars. So it is really the combination of all these elements. We know where the stars are, how they are moving, what is their temperature, and what are the properties of these stars. The most eagerly awaited result from Gaia are so-called parallaxes, which is the measurement which gives a handle to the distance of the stars. And this is a very tough measurement to be done. And we have known since Hipparchus, the previous ESA mission, distances to about 100,000 stars. And Gaia is going to increase that number to above 1 billion. So that is a real revolution.
The raw data from Gaia is used to create stunning visuals and animations. Obtaining the parallax measurement involved determining the apparent motion of the star by using 2 different vantage points along the Earth's orbit around the Sun, and separating it from the star's true motion through the galaxy. To do this, the spacecraft is orbiting around the L2 Lagrange point. The Sun, the Earth, and the Moon are all roughly in one direction, and the sum of gravitational forces makes it an ideal position to study the stars at the dark side of the sky. Closer to home, Gaia observed 14,000 known solar system objects too, mainly asteroids. The quality of data provides us pinpoint accuracy over time of these orbiting neighbors.
So we have a multitude of targets. We have solar system objects, asteroids. Most of them are stars, but we also see external galaxies and quasars. And it is really different kind of science what you can get out from this. From the solar system targets, we can measure their positions extremely accurately. We will know much better than ever before the orbits of asteroids, for example. Stars we are using to understand our Milky Way better. From stars we get really the structure of our galaxy. And the advantage of seeing some quasars is that the reference system of coordinates is based on quasars because they are far away, so they don't move. And we can observe them in radio. And now finally with Gaia we can see the same objects in optical wavelengths. So we can tie radio reference system to optical.
This animation of our own galaxy, the Milky Way, shows the roughly 100 billion stars. The location of the Earth's sun is shown here in one of the spiral arms. The Hipparchus survey is in red. It pinpointed the positions of more than 100,000 stars to a high precision. Gaia has surveyed up to 30,000 light years in all directions, encompassing 1.5 billion stars.